Okay, so next is eccentrically welded connection, or if there's a possible rotation that can be created dun sa connection natin. So, like your eccentrically loaded bolted connection that I have discussed previously, magkakaroon ng two types of forces to consider. We will have your direct force and then torsional force. But unlike your bolted connection na in terms of force tayo, now, so since this is welded connection, uh, we will solve it in terms of Q or force per unit length. Since hindi lang direct force yung kinocompute natin. I mean, by direct force, I mean in kilonewton. So, ang unit nung force natin is naka-newton per millimeter or kilonewton per meter. Okay, so yung first is components of the direct force or the effect of the force directly dun sa connection. So we have also the components of the torsional force or the moment created kapag meron tayong eccentric distance. Okay, so here, for the value of Q dx, again, ito Q tayo, hindi tayo P. So in terms of force per unit length, the force, direct force along x-axis divided by the summation of the length of the weld. Y component is the direct force sa y-axis divided by the summation of the length of the weld. Now for the torsional force, we have this equation. Again, kapag torsional force sa x na yung moment multiplied by the y, kapag sa y, moment divided by x. Now, yung denominator natin is given by this equation. This is also called as your polar moment of inertia na tinatawag. Given din to or annotated to as letter J. There are books na pag ang tinatanong sa inyo is J or polar moment of inertia, ito yung tinutukoy nila, itong denominator. So yan. Summation of the L squared over 12 plus XC squared plus YC squared of the individual welds. Ang ibig sabihin niyang subscript na C. Okay, so check natin. Then the T or the torsion or the moment is equal to the force times the eccentric distance. Yan. Yan. So T is the torsional moment, X and Y is the coordinate of any point on the weld measured from the centroid of the weld group. So like your bolt connection, may centroid yung group nun, meron ding centroid yung group ng weld. So X and YC is the horizontal and vertical distance of the centroid of a weld from the centroid of the weld group. So ito yung individual distance nung centroid nung individual weld dun sa centroid nung group. So, of course, same yung concept. To get the maximum intensity of the weld force or Q, we need to get the resultant of the direct force and the torsional force. So, yan, let's see. Yan, let's have an example. So here, a plate is attached to the frame of a machine by side fillet welds as shown in the figure. Determine the size of the welds to resist a vertical load of 150 kilonewton. Assume that the allowable shearing stress at the throats of the weld is 145 megapascal. So meron tayong FV. Now yung sinasabing determine the size of the fillet welds. Now since here given yung length ng welds, what we need is the thickness of the weld. Now, yun yung wala natin. So yun yung i-compute. What will be the thickness of the fillet weld given these distances? Now if you'll notice, hindi equal yung length ng top and bottom. No? Also, we have an eccentric distance because this P will create a moment kasi may eccentric distance siya. So, hindi pa natin alam yung E. Bakit? Hindi ba yung 250? Hindi po because ang E natin should be from the centroid of the group to 150. So, since hindi siya symmetrical, hindi natin alam if nasan yung centroid of group. But for example, parehas to 100, no, obviously, ang centroid niya is nasa 50. Now, since This is 100 and this is 200. We need to compute for the centroid of the group first. Since yung equation natin na pwede nating makuha yung thickness is by using your Q, which is equal to 0.707 thickness times the shear stress. No? So since given yung shear stress, pag na-compute na natin yung Q, we can compute for the T. Now, how do we compute for your Q? Now, di ba, to get the Q, we need to get the resultant of the force per unit length of the direct force and the torsional force. So, isa-isahin muna natin. Simula tayo sa direct force. For the x component, ito, y component. Now, since the force here is a vertical force only, so ang q dx natin will be 0. So, ang q dy natin, again, sum of the length. So, i-add lang natin yung length ng weld, which is 100 plus 200 plus 200. So, 500. So, yung direct force ng y is 300 Newton millimeter. Next is the components of the torsional force. So, before we can solve this, kailangan muna natin ma-solve yung T is equal to PE. Now, again, we don't have the distance E yet because hindi natin alam yung centroid ng group. So, here, no, kailangan natin itong i-compute kung ano ba yung location ng group. No? How do we do that? All we need to do is use your Varignon's theorem. So, magdodraw ulit tayo ng reference line. So, sabihin natin ang reference line natin is dito. Ito yung ginawa kong reference line, no? Andyan. Now, if we want to get dikit ko dito sa... Ito yung gawing reference line, di ba? Now, from Varignon's theorem, yung sum nung length, ayan, sum nung length times the location of the centroid of the group is equal to the equivalent length and centroid of the group. So, kung ito yung reference line, we have the total length 500. The total length 500, no? 500 times x. 500 times bar x. Individual tayo. So, simula tayo dito sa first weld. Ito. So, yung centroid ng first weld natin is nandito. Dito, no? So, since x muna yung hinahanap, so distance ng centroid sa x-axis dun sa reference point. Ito yung reference point. So, ang distance niya is 50, di ba? Since centroid ng 100 is 50, so itong length na to is equal to 50. So, 100 times 50. Check. So, okay na to. Next naman is itong line na to. So, ang centroid niya is nandito sa gitna. Now, yung distance niya dun sa reference point is 0 kasi nasa isang axis sila. So, 200 times 0. Check. Next is the length of this one, which is 200. Ang centroid niya is dito. No? Tapos distance nito papunta sa reference line is 100. So, 200 times 100 yan. Sorry. 100. So, therefore, we can now compute for your bar x, which is equal to 50. Now, naman, check natin yung reference, yung y-axis. Now, for the y-axis, same lang, no? Kukuha pa din tayo ng reference point to solve for the y-axis or centroid of the group along y. So, draw tayo ng reference point. For example, dito sa baba. Ito naman yung reference point natin. Tapos, i-drawing ulit natin yung mga individual centroids. So, yan. 500 times bar y is equal to the individual welds. First is itong 100 na to. Ang centroid niya is nandito. Now, distance of the centroid with respect to the reference point. Ito po yung reference point. So, this is equal to, yung distance nila ay 200. No, 200 mm. That's why 100 times 200. Next naman is itong Weld na to, andito yung centroid sa gitna. Ang distance niya sa reference point is 100. So, 200 times 100. Next is this one. Ang distance ng centroid sa reference line is 0. Yun. So, solving now the bar y equal to 80. Tapos, ang gagawin natin is ipa-plot natin siya. So, 50 from the reference line. Ito yung reference line. Move tayo ng 50. So, ayun. Then, 80. From the reference line, mag-move tayo ng 80 paakyat. No? Ayan, bar y 80. So, andito yung location ng centroid ng group. Again, why did we solve for the center of the group? Because this is not symmetrical. So, hindi lang tayo pwede divide ng 2, no? So, yan. So, once we solve the centroid of the group, if this is 50, and this is 250, kung 100 to 50 to, so this will be 50, tama? Ito natitira 50. So, the value of your E is equal to 250 plus 50. So, this is 300 mm. Now, we already know the value of your E. So, we can compute for your T. T is equal to PE. So, is equal to 150,000 times your E, 300. So, makakompute natin yung torsional moment. So, T is equal to PE. Then first, compute natin yung polar moment of inertia or the summation of the length times L squared over 12 plus XC squared plus YC squared. So summation, no? So we will get the polar moment of inertia of the 3 welds. So isa-isahin natin. Sige, hindi ko muna ito pakita para hindi kayo mahalitan, no? Yan. So una is natin yung color. Sige, yan na lang. So, ang L natin, itong AB is 100. So, 100. Sorry. For AB, yung length is 100 multiplied by 100 squared over 12. Ano ba yung x sa YC? By definition earlier, no, this is the distance of the centroid of the weld to the centroid of the group. So, kung andito yung centroid ng weld, ito yung centroid ng group, along x-axis, the same yung x-axis nila, no? So, ang x-axis niya is 0 squared kasi pantay sila. No? Ang distance ng x-axis nila is the same. Then y, or distance nitong centroid dito sa centroid, ang distance nila is 120. So, this is 120 squared. Next naman, BC. Ang length ng BC is 200. 200 squared over 12. So, drawing nyo muna yung centroid, no, para hindi kayo malito. The distance ng centroid papunta sa original centroid sa x, that is 50. No? Dito, papunta dito, that is 50. So, 50 squared. Plus, yung centroid papunta dito. So, itong distance na to. Ilan ba yan? So, if this is 100 and this is 120, ang natira is 20. So, ang distance nung centroid nung BC dun sa centroid ng group is 20 squared. And now, ang ating CD is equal to, ang length niya is 200 times 200 squared over 12 plus, ito yung centroid, distance ng x. So, if this is 100 and this is 50, so yung distance nila ay ito. So, this is 50. So, 50 squared. Plus, distance ng centroid dito sa centroid ng group is 80. So, 80 squared. Ayan. Then, compute nyo na siya individually. Ganito yung lalabas. Ayan na yung ayan yung ginawa ko earlier. Then since ang equation natin is the sum of this, so isum lang natin sila para makuha natin yung total polar moment of inertia. So we have 3,918,055.566 mm cube. So this is the polar moment of inertia of all the welds. Now, since we already have this, check na to. Check na to na. Ang kailangan na lang natin is yung T, which is just 150 times 300. Meron na tayo. So we have 45 times 10 raised to 6 Newton millimeter. Now to solve, ganito yung itsura ng forces. No? Ito yung QT at A, QT sa B, QT sa C, and QT sa D. Now, we need to compute the Q at point A and at point D. Since hindi nga sila equal yung length, iba yung magiging value ng Q sa point A, iba rin yung magiging value ng Q sa point D because magkaiba yung value ng Y tsaka X nila. So, tingnan natin. First, let's compute for the at point A. So, at point A, ang equation natin, eto. So, copy-paste yung T and na 45, tapos copy-paste tong polar moment of inertia. Now, bakit 120 yung Y? Kasi yan yung distance ng Y from point A. Kasi from point A, distance niya sa centroid ng group is, now, vertical is 120. Now, ang distance ng A, horizontal dun sa centroid ng group is equal to 50. So, yun na, 120 yung Y, 50 yung X. Now, kung components naman sa D, so compute na natin yung E. Component naman sa D, so palitan ko yung color. Component sa D, eto, ang distance ng Y, o vertical distance dun sa centroid ng group is 80. So there you have it, 80. Ang distance nito papunta sa centroid is 150. So you have here 150. Yan. So ang difference lang nung pag-compute ng QTX for A and D is the Y and X, or distance nung endpoint dun sa centroid. So we need to compute both and compute for the value of Q. Check natin, Q. So getting the resultant of the direct force and the torsional force at A, we will get 1632.32. And then the direct force at D will be 2221.69 Newton millimeter. So yun, magkaiba yung value. And then of course, we will get the larger value of Q. So kasi yung mas malaki yung stress, since magko-compute tayo ng thickness, we need to compute it based on the larger stress of the weld. So, since magre-design tayo, ito yung gagamitin natin so that mas larger yung makompute natin na thickness. Or para kayang i-sustain nung nung weld yung force nito. So, in a sense, if we will look at this welded connection, ibig sabihin pala, mas malaki yung stress sa weld nung C dito sa endpoint, dito sa point D, mas malaki yung stress mo sa point D comparison sa A. So, yan. Gagamitin natin yung 2221.69. Tapos, balik tayo dito sa equation na to. Q is equal to 0.707 TFV. Then, factoring out T, we will get this equation. Tapos, direct substitution na siya. So, we will have 21.67 or 22 mm. So, again, ginamit natin yung larger yung stress para ang ma-solve natin na value ng T is yung mas malaki. Kasi if ang gamitin natin is yung mas maliit, so mas maliit yung mga de-design nating thickness. So if mas maliit, ibig sabihin hindi niya kayang masatisfy yung force dun sa mas higher yung stress. So eto na. So in this case, we use the larger stress which is yung 2221.69 at point D. And then, substituting it here, we arrived with the thickness of the weld that is 21.67 or 22 mm. So, yan. Now, what will happen if, for example, may horizontal force, no? Ang changes lang naman ng horizontal force is that magkakaroon din tayo ng PDX, no? PDX. Or yung direct force X. Okay, so let's have another example. So here, a bracket shown is welded to a column flanged by an E70 electrodes fillet weld. It carries an eccentric load of 90. So compute the polar moment of inertia, which is your J. Then compute the maximum force to be resisted by the fillet welds. So yung Q. And then compute the size of the fillet weld if an E70 electrode fillet weld with FU 485. So size is yung thickness since given yung length nung weld. So in this case, if you'll notice, symmetrical yung CD and BA. So madali nating mahanap yung centroid ng group. Paano ba mahanap yung centroid ng group? Madali lang, diba? So andito yung centroid nito. So ang centroid nila is andito sa gitna. Dali lang mahanap. So if we are to compute for your E, no, wag na kayo mag-variance. Medyo obvious na siya sa figure kung nasan yung centroid. So ang E natin is, if this is 150, this is 75 plus 100, so 175. So ganun lang. Mas madali kapag symmetrical yung section because you don't need to compute for the tawag yan, centroid of the group. Kasi obvious na sa figure. No? Check natin. So, you have here two options for the polar moment of inertia. Since ang question is, let me see, polar moment of inertia of the fillet welds. Yan. Pwede nyo gamitin yung equation, mas madali. Instead of polar moment of inertia, if we consider 1 mm strip of the fillet weld, this is just the, kasi since ang name niya, no, polar moment of inertia, so this is just the moment of inertia of the fillet weld. So, ang equation na to is the transfer equation, BH I plus AD squared, di ba? This is I. Since dalawa yan and symmetrical siya, minultiply lang natin sa 2. Now, if we consider 1 mm daw, so ang magiging base natin is 1. So, 1 mm lang yung thickness o yung strip. So, 1 times the height, 150, cube over 12. Plus the area, 150 times 1. Tapos, ang D, bakit siya 75? Because ang centroid ng group is andito. Ang distance nung centroid ng individual is 75. Kaya siya 75 squared. If you compute that, makakompute natin yung J, which is 2.250,000 mm raised to the fourth. Now, you may also use the equation. Eto. Same lang dyan yung lalabas. Summation of length over L squared times L squared over 12 plus X squared plus Y squared. So, substitute lang natin. Ang total length is 150 times 2. So, 300. Multiplied by, so, in a sense, no, multiply na lang natin siya sa 2 yung entire section para isa lang yung i-consider. So, 150 times 150 squared over 12. Ang X niya is 75. No? Tapos, Y is 0. Baliktad ata. No? Ang X niya is nasa the same axis. Yan, tapos 0. Tapos i-add natin yan. Ang J natin is the same. So, you may use a 1 mm strip of fillet weld or you may just use the formula. Ito. To get. So, ito yung polar moment of inertia. So, this will be used na dun sa equation natin. So, yun. Check na. Again, multiply ko sa 2 because we have 2 welds. Para sana lang. Now, the maximum force to be resisted by the fillet welds or your Q. So, first, let's compute the direct force. Of course, wala tayong QDX. Meron lang tayong QDY. Ito yung pag-compute. Ito yung QDX. This is the QDY. Sorry. QDY. Ito naman, QDX. Ito, QTY. Ito naman, QDX. QDY. Tapos, kasi there are other references wherein hindi Q yung ginagamit, no? But small letter F, same lang naman yan. So, yung FY na to is your QTY. No? So, kaya ang kinukuha natin after natin silang makompute is yung resultant. Check natin. Direct force, again, wala tayong QDX because we don't have a force sa x-axis. Then, for the torsional, na-compute na natin earlier to, yung polar moment of inertia. Ito, na-compute na natin to earlier. Substitute na lang. Now, for the value of T, na dun sa centroid, which is 75. So, 100 plus 50, ilan nga, 75. So, 175 times 90. Yan. So, we have 15.75 times 10 raised to 6. Then, substitute natin dito. Yan. So, for QTX, now we don't need to check kung point D and point A because tulad nung sabi ko, symmetrical siya. So, same lang yung valueng lalabas. Kasi ang distance, for example, dito yung centroid, no? Sa gitna. Ba't ayaw? Nandito yung centroid. Clear. Dito yung centroid. So, ang distance nung D dito sa centroid ng group is the same with the distance nung sa A. So, this is 75. This is 75. So, the same lang sa A, 75 din to. Then 75. So, you don't need to compute it twice. You may just compute it once. Kasi equal sila. Then yon. So, nagkataon ang Y natin is 75. Ang X din natin is 75. So, we have the value of QTX and QTY. So, kunin na natin yung resultant. Ayan. So, direct substitution of the values that we got earlier. So, ayan. Ganito yung illustration, na. So, yun. Solving now, we have the maximum force to be resisted by the fillet welds is 977.88 Newton millimeter. Now, next is the thickness. So, balik tayo dito sa equation na to na ginamit din natin sa previous problem. Using the Q, we got sa letter B. So, yun. Direct substitution, we will have the thickness for this problem is 9.51 mm or 10 millimeters. Okay, so I think that's the last example for your welded connection. Yes, yan. So again, magkakaroon lang tayo ng direct force sa X kapag sabihin natin, for example, yung binigay na loading is inclined. Kapag inclined kasi siya, na magkakaroon siya ng vertical tsaka horizontal component. Vertical tsaka horizontal component. So, magkakaroon ka din ng direct force sa X. Yan. So, yan. So, that would be all.